So in the previous video, we have seen the drawback with this particular implementation of the hash table, that is values are being deleted when the hash is same. So this phenomenon is called as a hash table collision. In this video, we will see how to solve hash table collision. So as we have seen, right, in the current implementation, we are storing one value at a particular index. So to solve this hash table collision, what we can do is we can store multiple values at the given index. So let us go ahead and see that with the visualization. So in the example of storing locales and languages, what we do is we store an array of key value pairs in the given particular index. So the first index of that array will be the key and the second will be value. And in our example of fruits and their colors, when there is a conflict, we store the new key value pair in the next index. So now whenever there is a conflict, we insert a new thing here. We will not be overriding it. Since we have changed how the values are stored, get, set and remove operations will change. So let us go ahead and implement it. There will not be any change in the hashing function. It will remain the same. So in the set method, first we check if there is anything stored in that particular index. That is bucket is equal to this dot table of hash. Hash is nothing but the index of the table. So if the bucket exists, that means this scenario either we found this particular 0 or 3 as the index. Then if this particular bucket exists, then we need to check whether a key exists in this particular two-dimensional array. So what we can do is we can get the existing index as this bucket dot find index of item, where item of 0 is equal to past key, meaning this every row is called as a bucket, and within that bucket we find each item, and each item's zeroth index will have the key. So we compare each item's zeroth index with the key. So if you find the index, that is existing index not equal to -1, then what we do is bucket of existing index, that is this particular item, we update the value to the past value. So value is found at the index 1 and I'll set it as value. Else means that we found a bucket, but that particular key does not exist in that particular bucket. Then what we do is we just push it to the end of the array. Bucket, which is represented by this dot table of hash, we push a new key value pair array. So what this line does is whenever you don't find the key in an existing bucket, it pushes the key value pair at the end of the bucket. And one more scenario is there, we don't find the bucket at all. That is, let us say our hash function results in 1 and there is no items here. So we need to create an array, two-dimensional array here. So that is else case. That will be this dot table dot hash. That is nothing but the bucket is a two-dimensional array. At the 0th index, we enter key and value. So that's it about the set function. Now let us see the get function. Get function is similar to this set function. We get the bucket. So if the bucket exists, then we retrieve the existing index. If existing index is not equal to -1, that is that particular key exists, then we just return the bucket dot existing index of 1. We store key at the index 0 and value at the index 1. That's why we need to get the index 1. Otherwise, if we are not able to find the key, then we just return undefined. Now finally, let us write the remove function. I'll just copy paste the get function because remove is similar to get, and we just need to modify this one line. Let us say in our example we need to remove this melon. What we can do is we can splice the array with the given index. So if I call this dot table dot hash, that is this particular row dot splice of existing index, we need to remove one value. So that's it about the remove function. We will not change anything in the display function. Let us test this and see. So as you can see, our get function is working fine. We are getting color of apple as red, and we have inserted a lemon and melon here, and as you can see it is not replacing each other, and it is inserted as a new item in the array. And the delete is also working fine. We are deleting apple here. Apple was existing here and apple is removed here. So that's how we can solve collision in hash table. And coming to complexity, in all the get, set, and remove method, we are using find index. So the worst case complexity here is big of n, that is linear time complexity. But if we use efficient hashing algorithms, then we can almost avoid collision. So the average case complexity is considered to be big of 1 or constant time complexity. In the next video, let us see tree data structure. Hope you're liking this series. If you are, please consider subscribing to the channel. See you in the next one.